This is AP Calculus ABB, the definite integral, Unit 2, Lesson 3, Antiderivatives. I think today's lesson will be quite a bit shorter than yesterday's video, which was 20 minutes long. The idea of the integral is that it is finding the area under the curve. Now we're going to look at another property of the integral, and it's called the antiderivative or the underivative. Let me show you what I mean. So if I want to take the derivative with respect to x of, say, x squared plus 2x plus 5, right? That by the power rule and the distribution rule here is 2x plus 2, right? So what we're looking at now is doing the opposite. We're going to go backwards. We're going to take the answer to a derivative and find the function that we derived. It's called the antiderivative. Antiderivative. Okay? And the fundamental theorem of calculus is going to link the antiderivative with the integral and demonstrate that they are really the same thing, with some slight variation. Okay, so we're going to let's write this out here. I want to find the integral of 2x plus 2, and notice I don't have boundaries now, no boundaries, and I'm going to say with respect to x. The integral of, you might say, is x squared plus 2x plus 5. But there's something else we should know here. What if I take the derivative with respect to x of x squared plus 2x plus 7? That also is 2x plus 2. 2x plus 2. Okay? And it could be the same regardless whether the 7 was a 9, a negative 2. There's simply no telling what that number is. That's information that is lost. Because remember what a derivative is. A derivative is telling me the slope of the function at any given point. So the slope of the function f is the same whether it's down here or up here. So if I add or subtract some constant, plus c or minus c, I do not change the derivative. I do not change the slope given the x value. So the same thing is true here. So when I take the antiderivative, I'm seeking to find the function that I took the derivative of. But there's no way to know what that constant was. That is lost information. And so for an indefinite, we call it an indefinite integral for this reason. Instead of putting 5 here, because I would have no way of knowing it was 5, I insert a c, a constant, a capital C, and it's universally accepted as it's the constant of integration. Okay. Now, if I want to find the constant of integration for a particular situation, sometimes I can use information from the problem in order to find the constant of integration. For example, let's say you happen to know the acceleration. You guys remember these. We dealt with these problems last semester. The acceleration is negative 32 feet per second squared. What is the velocity as a function of time? And the acceleration is a function on time, though it's constant. So the velocity as a function on time is the derivative of velocity is acceleration. So it is literally the integral of acceleration dt, right? It is the integral of negative 32, or the antiderivative of negative 32 dt. Well, what function, if I take the derivative of the function, what function gives me a constant of 32? The answer is 32, negative 32 t, but plus some unknown constant, right? And now I can use some initial values. What if the initial velocity were 15 feet per second? Now my antiderivative, my velocity function of time, becomes negative 32t plus 15. Okay? Because that would be the velocity at t equals 0. When you insert t equals 0 and negative 32t, you get 0. And so 15 would be the value that's left over. Right? So hopefully that makes sense. When we take an indefinite integral, we end up with this constant of integration, c, to represent the constant that could be derived out. All right. That said, this really becomes about knowing your formula. So all your identities that you learned before about derivatives apply here. So the derivative with respect to x, whoops, changed to, I need to go there, okay. Derivative with respect to x, d dx, of x to the n, okay, is, you remember the steps, put the n, multiply by n, and decrease by 1, right? When we think of inverse, we do the opposite operation in the opposite direction, in opposite order. So the integral of x to the n dx is, instead of multiplying by n and then decreasing by 1, I'm going to do the opposite in the opposite order. I'm going to increase by 1, x to the n plus 1, and I'm going to divide by n plus 1, plus a constant of integration. Okay, so let's just do a little bit of a practice. What if I said the derivative of x to the 5th? Increase 5 by 1, that's x to the 6th, and divide by 6, plus a constant. Let's check. To check, take the derivative of your integral. The derivative of x to the 6th over 6 plus c, bring the 6 down in front, is 6x to the 5th over 6 plus 0, because the derivative of a constant is 0. 6's cancel, leaves x to the 5th, and we're back where we started. Okay, so hopefully that makes sense. Increase the exponent by 1 and divide by the exponent increased by 1. Some other common derivatives that you may recall are the derivative of sine, is cosine. So the integral of cosine dx is sine plus c. You may recall the derivative of the natural log. The natural log is 1 over x. So the integral of 1 over x dx is the natural log of x plus a constant c. You may recall the derivative of e to the x is e to the x. So the integral of e to the x dx is e to the x plus c. The derivative of a to the x, this is the power function as opposed to, well, the exponential function, is ln a to the x, or a to the x ln a. Okay, so the integral of a to the x, do the opposite in reverse order, right? Instead of dividing and multiplying by ln a, we're going to divide by ln a. A to the x divide ln a plus c. Okay, just to give you another example to see how far it can go, the derivative of arcsine is 1 over 1 minus x squared square root. So the integral of 1 over 1 minus x squared square root dx is arcsine plus c. And my favorite one, this is my math joke, my dad joke, for math dad joke here. The integral of d cabin over cabin, where cabin is the variable, equals log cabin, it's actually log base e, log cabin plus c, which is obviously houseboat. Okay, so there you have it. I told you this would be a little shorter. Then this is just the idea that the integral is in fact the antiderivative, and we can find an indefinite integral by doing the derivative backwards, figuring out what derivative ends up here, and then adding a c, a constant of integration, to the whole function.